Hi everyone! We are almost out of control chart land. This is the last week we're going to be going over control charts for a little bit, but before we totally walk away from control charts, I want to talk about quality rating systems. So right now, when we've done control charts for attributes, we haven't put any weight on what those particular attributes are. So are they serious defects? Are they minor defects? We don't know. We're counting them as the exact same weight. But let's take a look at a system where the particular defect does make a great deal of difference into how that particular product is received. And that product is milk. So here we go. Here's 3 bottles of milk. And if you think about the best milk you ever had and the worst milk you ever had, it's pretty much a night and day difference. And I guarantee you that you have been drinking defective milk pretty much your entire life. And you might be thinking, well, no, I know when my milk is sour, I am definitely not drinking defective milk. It tastes fine. Well, unless you have bought milk in completely opaque packages your whole life, yes, you have been drinking defective milk, because milk light oxidizes very easily. And if you're trained to pick it up, and I am, then you take one drink of that milk, or you can even smell it, and you say, ooh, that's really light oxidized. That does not taste good. So here's a list of very common milk defects. So if you take a look here, we have all sorts of different defects, including that light oxidized, which if you are buying those big gallon jugs of milk, yes, it's light oxidized, and you can taste it. And here, with these numbers, we have scores for those, and these scores are out of 10 possible points. So these are flavor defects, and you can see that some of them have a lot lower scores than others. For example, flat, which just means that there's no real dairy taste to your milk. It tastes a lot like skim milk. It's just kind of watery. Out of 10 points, this isn't bad compared to what's right above it. Fruity fermented, which by the way tastes like pineapple juice mixed with soy sauce. It's not that pleasant. And it's what happens when you get a certain bacterial contamination in your milk. So this, if it's bad enough, can drop your milk score all the way down to 1. So we have 2 different defects here, but they're clearly not the same severity. So how do we deal with that if we're doing some kind of control chart based on what flavors we are looking at in our milk? Well, we need to weight our nonconformities or our defects somehow. And you can see this scoring is a way to weight how severe these defects are. So sour milk, for example, very, very severe defect. Even a slight amount of acid will have any consumer going, ooh, this is bad, I need to dump it down the sink. Versus if you have cooked milk or flat milk, it's not that big a deal. And in fact, some consumers really liked this cooked taste. So if you're on the West Coast, Dairy Gold ultra pasteurizes all their milk. It gives it a cooked flavor. It sort of tastes like custard. It actually gives it a fuller mouthfeel. It tastes like it's higher in fat than it actually is, and it's pretty good. But it is not considered the U.S. standard for perfect milk. So it is technically a defect, even though some people like it. But because it's not as severe as something that's acid, it has much higher scores. So if we were going to weight acid versus cooked, we would give a lot higher weight to acid than cooked. So let's look at how to set up our quality rating system accordingly so that when we're going through and putting down all these different defects for milk, we know how severe our defects are. All right, here is a sample Excel sheet for creating a quality rating system. So we have our subgroups and our number inspected. Here we have the bare minimum for making our U chart, which is what we're going to use our quality rating system in. You can only use one in a U chart because it is fraction count of nonconforming. So you can't do nonconforming units in a QRS, but you can do number nonconforming, and it has to be a fraction. This is the only one it works with because the fraction takes care of different numbers of inspected. So, got to be a U chart. Having said that, we have our number nonconforming here, but we need a U chart, so we have to calculate proportion nonconforming. And the way we do that is we say that is the number of nonconforming divided by the number of inspected. And there we go. There's our proportion nonconforming. So we'll just fill that down. And now we have all our data for this column. So this is great if we wanted to make a regular U-chart, but we want to make a U-chart that incorporates our quality rating system. So we have to keep going and split out our nonconformities into critical, major, and minor. And I've already done that. So to calculate critical nonconforming, it's the same procedure. So you take the count of critical nonconforming and you divide it by the number you inspected. And if you're saying, well, wait, why do I divide it by the number inspected? Why don't I divide it by the number of nonconformities? Well, you're still counting nonconformities out of your entire sample. So you do need to divide the count of whatever nonconformity you're looking at by your total sample number. So here, this says 0.00, and we're thinking, ooh, well, that is 0, because we had 0 critical nonconforming. So we're going to have 0 come up here. And if we fill down, we can see that if we do have a critical nonconforming point here, our value goes up. So don't be worried if you get a 0. If you have 0 nonconforming, 0 divided by anything is going to be 0. So just don't worry about it. Let's do our major nonconforming. Same procedure. Major divided by total number inspected. And you fill down, and this column is done. Our minor is already calculated for us. Same thing. Not a big deal. And then you want to calculate, after all of that is done, you've got all of your proportions nonconforming of your various nonconformities. Now you need to weight them. And so I'm going to do that here. So I'm going to say, okay, we have a certain weight criteria for our critical nonconforming. It's a heavy weight because these are really, really bad nonconformities. This would be like sour milk. You cannot sell it. No one's going to buy it. So that gets a heavy weight. So here's my weighting factor for my critical nonconformities. And so I will multiply it by this, my fraction nonconforming in my first subgroup. And I'm going to add to that, because I still have more nonconformities, my weight for my major nonconformities. Now this is something that's pretty bad, but your product is still okay. It's not as high quality, but it's okay. And so this would be something like very, very cooked milk. And you may be thinking, I thought cooked milk was a good thing. Well, not when you really, really cook it. You cook it too much and it actually tastes like burnt hair. And yes, I have had milk that was cooked that bad. It tastes very interesting. No one likes burnt hair, so that one's pretty bad. So that's major, and we will multiply it by our major proportion nonconforming. And then finally, we are going to add in our minor nonconformities. And these are just little things that aren't too bad. So maybe a very slight cooked flavor, a slight flat flavor, something like that. Or it's, this isn't the best milk ever, but, you know, it's okay. I'll drink it. I'll put it on my cereal. So we'll take that weight and we will multiply it by our minor proportion nonconforming. Now before we say okay and accept what's in here, we're going to need to lock our particular rows for our critical and our major and our minor nonconforming weights. And that way when we fill down, like so, these cells don't scooch around on us. So you can see that we're still referencing the same 3 cells that we need to reference, which is good. All right, so if we were to take a look at our chart now, we would basically see a run chart, but we need to put our limits on. And to do that, we need to calculate our center line and our sigma 0 value, which is basically our variance for this. And to do that, we actually need to incorporate the weighting into our center line and into our limits. If we calculate regular U-chart limits, they're going to be way too low because we weighted those critical and major nonconformities higher. And so everything is going to be skewed unless we take those weights into account. So to calculate D0, our center line, we are going to take the sum of the averages times the weights. And so what that looks like is we have our average critical nonconforming times our weight plus our average major nonconforming times our weight plus our average minor nonconforming times our weight. And there we go. There is our D0 value. Now for calculating sigma 0, our numerator gets pretty complicated. So instead of calculating sigma 0 all in one go, I'm going to calculate the numerator separately and then calculate sigma 0 so I don't have to spend 5 minutes hunting for the stray parenthesis that I missed. So our numerator is the sum of the weights squared times our averages. And what that looks like is our critical nonconforming weight squared times our average critical proportion plus our major nonconforming weight squared times our major proportion plus our minor nonconforming weight squared times the minor proportion. And that's our numerator value. Now we can calculate sigma 0, and that is the square root, and that's our square root function of the numerator divided by our total count inspected. Not the average number per subgroup, but the total count altogether from all our subgroups. And there's that. So we've got our center line, and now we have sigma 0 for calculating our action and warning limits. Our action limits are the center line plus or minus 3 times our sigma 0. Our warning limits are center line plus or minus 2 times our sigma 0. So sigma 0 here is standing for a weighted variance. All right, so to calculate that, upper action limit, we have our center line plus 3 times our sigma 0. Lower action limit is center line minus 3 times that sigma 0. Upper warning limit, center line plus 2 times sigma 0. And lower warning limit is center line minus 2 times sigma 0. And there we have it. There are our center line, action, and warning limits. And so if you were to plot all this on a chart, here comes our little chart. There we are. So we have our points. You can see them oscillating all over the place. And we have our black center line, orange warning lines, and red action lines. And if you take a look at this process, you can see that it's a bit of a disaster. We do not have a well-controlled process at all, at least in terms of our non-conforming units. We have major spikes here, major spikes here, a huge drop here, which actually is a good thing if we were having this many non-conformities and we managed to drop it to 0 the next time. Too bad that's not repeatable, because our data are just bouncing all over the place. And so what this chart is showing us is that we have very poor control of this process. Sometimes we do great and we have very few nonconformities, and sometimes we do terrible and we have a lot of nonconformities. Now keep in mind, since we have weighted nonconformities, one critical nonconformity can really spike our data. And so that's something you have to remember when looking at these quality rating systems charts, is that you could potentially have 5 minor nonconformities and still have a point that is lower than 1 critical nonconformity. But if you think about, can I sell my product with nonconformities, you may be able to get away with a few minor nonconformities if your customers are not too fussy about quality. But a critical nonconformity, no, you can't sell that product. Your customer is not going to eat it. They are not going to want to use it, and it may actually hurt your brand to try to sell it because you are getting the reputation of selling something that doesn't work or something that doesn't taste good. So you have to be careful when analyzing these quality rating systems charts, but on the other hand, they can give you a really good idea of how bad are your nonconformities, what's your variance based on severity of your nonconformities that are popping up from subgroup to subgroup. And did your quality efforts reduce all nonconformities, or did they just reduce a couple of minor ones and you're still having a problem with major or critical? So that wraps up quality rating systems. Consider using these in your course project if you see a good fit for the data. They are a good chance to kind of weight your data to see, okay, is this a really bad problem I'm experiencing, or is this a minor problem? Either way, have fun playing around with them, and if you have any questions, feel free to let me know.